All right, so we're going to talk about function notation to begin with. So here, let's start off with something that everybody is familiar with. So if I write this down for you, y equals mx plus b. Okay? What type of notation is this? What is this? We've said this before in the past. How do you recall what type of a line this is, and what form is this in? That's the question I'm asking. What form is this in? You're close. Not point slope form. They give you a slope and they give you something else, the b. Slope intercept form. Good. So all this stuff is in slope intercept form. Okay, now I'm going to change one thing for you. I'm just going to change one thing. That thing that I'm going to change is this. Okay, what did I change? Yeah, I changed the y to f of x. That's the only thing I changed, correct? So I changed the y to an f of x. Everything else stayed the same. You guys agree with that part so far? Yeah, well, we call this is function form. So that's function form. They represent the same thing. It's just called function form or function notation, right? And in this case, it's a linear function because it still represents a line. So one thing that we can do with this is we can evaluate functions. And we evaluate functions very much like we plug in and solve for y in linear functions. So it's all the same, just has a different kind of a name to it, or a different sort of a look. So let me give you this function. What if I said, okay, I know that f of x is equal to 2x plus 5. All right, f of x is equal to 2x plus 5. By the way, that's how you read this. You read this as f of x. f of x is 2x plus 5. Do you guys notice that there's an x variable right here in the parentheses, and there's also another x variable inside the actual function itself? Do you guys ever notice that those match up? No. Well, now, do you notice that they match up? No. Those match, right? So here's what I can do. To evaluate a function, if I want f of 1, that means I take 2 and I substitute in a value of 1 for x, and I keep everything else the same. So notice that if this is a 1 here, then this has to be a 1 there. And notice that these match. You guys follow along with that? Okay, well, that means that, well, what's just 2 times 1? That's just 2. And how much is 2 plus 5? 7. This is 7, right? So therefore, it must be the case that if I plug in a 1, out pops a 7. And that happens to be a coordinate point on the plane. If I plug in a 1, out pops a 7. All right? You guys, let's try this one. What is f of 0? Go ahead and evaluate f of 0. Got something down there. Okay, so when you plug in a 0, what do you get, Rodney? What'd you come up with? He got 0,5 as an answer. He says he got 0,5. Can you show me or tell me what you did to get that? Yeah, so that should give you 2 times 0 is 0 plus 5 is 5, right? So again, whatever we put here, you have to put here. Okay, we'll do one more. Same function. What is f of negative 3? Go ahead, plug in. Zillion up high. Okay. Okay, when you plug in f of negative 3, what'd you evaluate? Omar, what'd you get, buddy? So you did like 2 times negative 3 and then added 5. Is that right? Okay, good. And you notice that whatever we have here when we evaluate the function, notice that those have to match all the way down the line, right? Those are matching. So, what's 2 times negative 3? Everybody, help him out. 2 times negative 3. Negative 6 plus 5. How much is that? What'd you get, Omar? Negative 1. And what's the point on the graph? Negative 3 comma negative 1. Very, very good, okay? So that's called evaluating functions, right? Does that make sense so far? Okay, put your hands up if you're with me. That makes sense. Show me like a 1, 2, or 3. Show me where you're at, okay? Let the record show almost everyone in the room is a 2 or a 3. Very good. Awesome. All right. Okay, next thing we're going to do is we're going to evaluate. We're going to evaluate functions, but we're going to do it a little bit differently in this case. Okay, there's 2 ways I want you to do this. So we have the first one where we plug in x value, but this one's going to be a little bit different, okay? So here's the directions. The directions are going to read this. Find the value of x. that makes f of x equal to 10. All right? Find the value of x that makes f of x equal to 10. And here's the function I'm going to give you. F of x is equal to 3x plus 1. All right? Here's the function that we're working with. F of x equals 3x plus 1. I'm not asking you to evaluate a function like what's f of 0, what's f of 9. I'm asking you to find the value of x that makes the entire function equal to 10. Does anyone think they got it? Anyone think they know what it is? What do you think it is, Aaron? 3. You think it's 3? Why do you think it's 3? Yes, he's absolutely right. He says you plug in 3, and 3 times 3 is 9, 9 plus 1 is 10. So essentially what we're doing is we're setting f of x equal to 10. So basically we're saying 10 is now equal to 3x plus 1, and we solve for x just like Aaron did. So we're going to subtract 1. So we get 9 is equal to 3x. We divide by 3's. So x must be equal to 3. Does that make sense? Okay, good. Okay. Yeah, I'll show you. I'll give you another one, okay? Here's another example. Find the value of x that makes f of x equal to 24, and the function I'm going to give you is this one. F of x equals 6x minus 6. So different example, same directions. The linear function is 6x minus 6. What value of x would produce a 24 when you plug it in? He says 5. Sergio, how'd you do that so fast? Tell me what you did. That's absolutely right.
6 times 5 is 30, minus 6, 24.
Perfect. So we're essentially taking 24 and plugging in 24 equals 6x minus 6. Adding 6 to both sides, we get 30 is equal to 6x. We're going to divide by 6's, and so x is equal to 5. So while you're getting set up for the big coordinate plane here, which one's quadrant 1?
Oh, that one.
Which one? Top what?
Left.
Top left? Top right. This is quadrant 1 up here. All right, good. Where's quadrant 2? Top left, quadrant 2, very good. Where's quadrant 4? Bottom right, quadrant 4. Where's quadrant 3? You got it, the only one left, good. Okay, if you have the first one, the graph that we're going to do together is going to be f of x equals, so number 1 is going to be f of x equals x. So f of x equals x. And we'll make a little tiny table for this one, x and y. Okay? If I plug in 1, what do I get out? What's f of 1? 1, good. If I plug in a 2, what do I get out? 2. If I plug in a 3, what do I get out? 3, right? So, those are these points right here. 3, 3. So, this is the first function that I want us to take a look at. And this is the function f of x is equal to x. Okay, let's talk about this function. Does this function has a positive slope or a negative slope? What do you think? Positive. Why do you say positive? Because it's going up from where to where? From left to right. So our slope is positive. What is the y-intercept of this function? The origin. So that means it's which type of a function? Direct variation. Nice job, Ross. Very good. Okay. All right, we're going to graph this function. I'm going to use a different color. Okay. I'm going to say f of x is now equal to 2x. F of x equals 2x. And we're going to make a little graph here. X and then f of x. So if I plug in 0, evaluate. What's f of 0? 0. Very good. What's f of 1? 2. Very good. And what's f of 3? 3 is 6, right? Okay, good. Let's plot those points. So 0, 0, 1, 2, and 3, 6. So that would be this point over here. Whoa, sorry. 3. I'm over here. Sorry. Good. And let's go ahead and graph that. And here's the function f of x equals 2x. What's the slope of this line? F of x equals 2x. Is it positive or negative? It's positive. Why is it positive? Why is it positive? Because it goes up from left to right. Okay, good. What is the actual slope of this line? There's a number to it. What's the number associated with it? What's the rise over the run? Is that the rise or is that the run? The rise, yeah. So for every 2 units I go up, I go 1 unit over. 2 units up, 1 unit over. 2 units up, 1 unit over. Right? That's my slope. All right? Is this a direct variation? Yes or no? How do you know it's direct variation? Because it goes through the origin. Absolutely correct. Okay, last one that we're going to graph together is going to be this one over here, the number 3. And it's going to be f of x equals negative x minus 1. Negative x minus 1. This is the last one we're going to graph together. So here's x, and here's an f of x, and we'll make a few points here. If I plug in 0, what is f of 0 for this function, negative x minus 1? What is it? Negative 1, good. If I plug in a 1, what is the output of this function? If I plug in a 1, I get a negative 2, right? And if I plug in a 2, what do I get out of this function? Negative 3. Good, let's plot these points. So 0, negative 1, here we go. 1, negative 2, and 2, negative 3. So it looks like this. And here's my function, f of x is equal to negative x minus 1. Okay, is the slope positive or negative? Negative. How do you know the slope is negative? Because it goes down from left to right. Good. Is it a direct variation? No, why not? Doesn't pass through the origin. What is the slope of this line? 1 over 1? Positive 1 over 1? Yeah, for every unit down, I go over to left 1. Down 1. Down, over to the right 1. So the slope is negative 1. Very good. And what's the y-intercept of this graph, of this function? Negative 1.